Hello, my name is Josh, and I'm a SCADA student at Mitchell Tech, and this is my logic that we are going to be seeing running. Um, we have first up our communication for our heartbeat, just a flip-flop timer that's turning on a bit. We got our startup sequence that is just the first scan bit that's turning it on. We got our handoff auto, and then our add-on instruction that is dealing with our flashing bits, just turning a bit on for a second by a timer. Um, then after that startup sequence is done, we are turning our conveyors on and getting a product up to our sensor, essentially getting it in line to get it ready to be dealt with. After that, we are then looking at all of our devices to make sure they're all connected and all ready to go before we are saying that we can even begin to look at anything. We have two separated system enable and then a ready to run. My system enable is essentially just a safety okay. I did it this way so that I can have a little more precise troubleshooting if anything goes wrong because it can be not ready to run because an in-tank pump got kicked off because of some reason, but our system could still be enabled. Um, so that just helps out a little bit. Our intake ready enabling is next, followed by our storage tank enabled. We need to have our intake um, enabled, and then we need to have either storage tank 1 or storage tank 2 enabled before we can be ready to run. I did it this way because we don't want to be taking in product unless we have ideas where to go with it, because if product sits in a tank, then we're just losing money on it. Um, we have then fill for a full logic right here that just says if the level meter detects that we are at 9, then we are full. And once we're full, we're just automatically going to flick on storage tank 2. As you can see down here with that full bit under all of those branches. We have the same thing under storage tank 2 just to make sure we have that repetition where we can do it both ways. If one of those storage tanks are enabled, then we are storage tank ready, which then that goes all the way back up to our system enable and are ready to run to make sure that we are have at least one tank ready. Then after all that is ready, then we can finally do in tank and we can fill the tank for as long as we need, and then once we are full, we can then deal with this add-on instruction that is just saying, hey, we're full in the in tank and we need to discharge it and put it into a storage tank. Which one do I put it in? Then right below that, we go into once we are done transferring, or if ready to run becomes not true at any point, we are going to turn everything off and we're going to essentially reset it and get everything ready back to how it was at the beginning, so that we can start taking product in and we can get it back going again. Here, this is saying once we are full in any one of the tanks, then we are going to change the discharge valve to 10. So that's essentially saying once we're full, we don't need that product anymore, we can get rid of it. And then once we're no longer full, we can go ahead and return those valves back off. Again, getting them ready to go. And now we're getting into our fault logic. We have a filling fault logic, and then we have a discharge fault logic. That's just saying, hey, if I'm telling you that you should be discharging and your value is not changing, that is a problem. So if it's not changing for 3 seconds, we are going to turn off the machine so that nothing else can and will go wrong. So we have that for the intake tank, the storage tank 1, and then the storage tank 2. Just copy paste the logic. Here we're getting into our physical where we're telling our drives when to run, how fast to run, and when to stop. Then we are getting into our motor starters, telling our motor starters when to run, when they should be going. And now our lights for our storage tank, that is all that is. And then we go into our more precise fault logic where we're telling which specific frequency drive or what specifically has gone offline. Then we have navigation for in the program, and then our startup sequence. This is where we're actually dealing with those bits and we're flashing a light for just a second. Here is now the simulated logic or the simulated software that I'm using in the scene that I created. We have the intake tank at the front. We have storage tank 1 at that back right. And then we have storage tank 2 at the back left. We have where the operator would be standing and operating everything. And the conveyors, which is simulating that a truck or whatever is bringing in the liquid is getting into place and is ready in place when it is at the laser. Here are the drivers, so all of the stuff that I have used and I am calling out in my program, we left some open just in case we wanted to add some functionality and anything to it to make it run better, more precise, or whatever we needed to. Here is my CAD drawing. Um, in my brain, it made more sense to have different CAD drawings for individual parts, so I could make it a little bigger. So we have inputs on one, for PLC input card 1, PLC input card 2. Then we have our outputs, and then we have our .io inputs, and then our .io outputs right here. I did make a mistake where I had the .io outputs connecting to ground. I did fix that though, just right after the recording of this. Forgot to film a new part. This is the starting sequence where we are flashing certain lights. I only went to a certain amount of points because by the time I got to this part right there, all my VFDs and everything were ready to go, so I didn't feel a need to keep it going. That's just me clearing a fault right there. This is my navigation for cameras in the sequence. So you got the controller, conveyors, and then you got the tanks themselves. So this is just for easy access so you can see specifically what's going on at these events. And if you wanted to jump around at any point, you sure can. Here you can see the process of the conveyors moving and then the intake, and you can actually see the motor starters that are controlling the conveyors. And then for that valve for the intake or any of the storage tanks, we have VFDs right here that those are being controlled by. So if you look at that far right one, it's getting turned to 60 and then 0. That's just saying, hey, that valve is full blast, and then it's turning off. Full blast, turning off. Then up at the top left, we have our PLC. We have top right, we have our network switch. Our whole panel view is at the top. Push buttons light, .ios, more lights, more push buttons. Again, the motor starters. And then here is my HMI running. Here is my trends page. Being a little slow right now. I don't know why. Has been being a little slow recently. But you can see each color stands for different things. I called those out specifically just off the screen. Here's my alarms page, so that'll say specifically what happens when it happens. So now I am starting it up. There's my system enabled. My intake tank is now ready. And now we are turning on my tank 1, my storage tank 1. And now my system is ready. Now we're going. Now, based on all that happening, this is what's going on. I started it here just so we can see specifically all the states. We can see it filling to its set point, and then we can see it transferring. And not only can we see it transferring, but we can also see it switch to the other tank automatically, and we can see what happens to that liquid in the first tank once it becomes full. Some of the hard stuff that happened here was dealing with the AOIs. I wanted to do it as an add-on instruction just because I think it makes it a little more clear at what you're dealing with and what you're looking at. And it kind of just makes the logic look a little more clean. But with that, it does bring on its own challenges. And so working through that, getting through bits turning on when they're supposed to turn on, and different parameters. Here we will see now the transfer. of liquid from storage tank 1 to storage tank 2, and now storage tank 1 is now draining. That liquid is not going anywhere. That liquid is just draining to nowhere, and then the liquid that is in tank 1 is the liquid that is now going into tank 2. And then we start back up like nothing happened. The system is the same way in hand mode, just hand mode. You would have to hold a button in order to do everything. I didn't get around to doing that because I had more problems with getting my HMI into my panel view than I thought I would have. This is now my IO map. You can see on the right side is my point IO, and on the left side is my actual PLC. So this is the bigger one, but there's a lot more spares. Just means there's a lot more points to deal with. Um, and the point IO has all the push buttons and lights. This is my bill of materials list. So this is everything that I used in the panel. The terminal blocks and the push buttons I estimated on, just because I didn't want to count all the terminal blocks. There was way too many to count. Everything else should be pretty precise to exactly what I used. And then the estimated price at the bottom is for the whole project, how much it would cost for the whole project. This is all for refurbished stuff, so it's not for brand new top tier, right out of the box stuff, just so you know. Um, it's all refurbished or off eBay. But thank you for your time.